we're going to look at an object such as a golf ball and see what happens to it as it is in free fall. The main question that I want to answer is, how many seconds will it take for an object that is falling straight to the ground to reach its terminal velocity? Don't write this down. We're going to write down a chart that helps us answer this question. In order to look at this free fall due to gravity, this is where we do want to start writing our notes. This will be the title of the notes. We need to know three things. The first thing we need to know is the time that this object is falling for. The next thing we would like to know is the force of gravity or acceleration due to gravity. And we write this with a capital F standing for force and a subscript lowercase g for gravity, force of gravity. And then we need to know the object's velocity, because again, we want to know how many seconds time it will take for an object to reach terminal velocity. That's the highest velocity that it can reach when the only factor that is affecting it is gravity. Air resistance will prevent it from going any faster. So if we hold that object at a very high height, and before we release it, the time is going to be 0 seconds. Gravity, no matter what, gravity on Earth always pulls objects toward the Earth at a rate of 9.8 meters per second squared. And then, because we haven't released that object, its velocity is 0 meters per second. Once we release the object and it falls for 1 second, gravity is still pulling down at a rate of 9.8 meters per second squared. That never changes, but its velocity has increased. And that object, after falling for 1 second, is now going at a velocity of 9.8 meters per second. The way I got 9.8 meters per second is acceleration times time to get rid of that squared. After letting it fall for another second, gravity is still pulling on it at a rate of 9.8 meters per second squared, and its velocity after falling continuously for 2 seconds is now 19.6 meters per second. After we let it fall for another second, for a third second, gravity is still pulling it down towards the Earth at 9.8 meters per second squared, and now its velocity towards the Earth is 29.4 meters per second. If we continue to let it fall for 4 seconds, gravity is still 9.8 meters per second squared. Now it's going at a velocity of 39.2 meters per second. After it's falling for 5 seconds, gravity is still 9.8 meters per second squared, and it is at a velocity of 49.0 meters per second. Remember, what I'm doing here is 9.8 times 5 equals 49. 9.8 times 4 equals 39.2. After falling for 6 seconds, gravity is still pulling it down at a rate of 9.8 meters per second squared. Its velocity is now 58.8 meters per second. And so, if we go back to our original question, how many seconds will it take for an object to reach terminal velocity? We need to figure out what the equivalent speed, and don't write the speeds down here, but the speed compared to velocity, 9.8 meters per second is 21.9 miles per hour. Terminal velocity of objects that are falling is about 122 miles per hour. So that means somewhere between 5 seconds and 6 seconds, that object will reach 122 miles per hour. Turns out to be just over 5.5 seconds. So answering our question, how many seconds will it take for an object to reach terminal velocity? About 5.5 seconds. The only things you should write down in your notes are this chart right here.